This is our website's main login page and allows the user to sign in, requiring an email and a password. And on our server, the email is what's used to identify the person. If a user wants to register an account, they can click this link, and it'll take you to the account registration page. And here we require an email, full name, and a password. Now, the full name for the user is really just for them. It doesn't really do anything for our server. And then here, I'll make an account right now. With a name. The name can be anything really. We have to check for that. And then I'll make a password. And so our password, the requirements for our password are that it needs a special character. Here, let me just put in a bad password to illustrate what we have. So these are our password requirements. You have to meet 3 out of the 4 of them in order to register an account. So now I'm going to put in a good password, and I'll register the account. And once you register, it takes you directly to the sign-in page. Then I'll sign in. All right. And then for our page, we can manage our account details through this drop-down menu up here. So we click that, go to Manage Account. Incidentally, this can be accessed from any of the pages on our website. For example, if we go to Activities, then Activity Summary, it's there. Activities, all still there. And I'm going to change my account details here. So each of these tabs updates a different thing. Incidentally, though, you can update multiple fields by entering in values for these fields and then just putting in the password. For every account detail change, the user will need to enter in their password, including their name, which, as we've stated, doesn't really do anything. But here, I'll change it right now. So change my name. And it displays the name updated page, and then if we go to our home, you can see that the name is indeed updated. And similar things can be done for the password and the email. So here I'm going to try to update both of them at the same time. Incidentally, if the passwords don't match, the client will throw you a message saying that the new passwords don't match. Now I'm going to update the email. Right, and successfully has updated both of the fields. So if we go to our home, you can see those changes. You can see that it's now the other email. And then if I sign out, using the new password, and as you can see, we signed in. These are the routes handling the user's information. These routes are all inside the user's route for our server. And so this first route is the sign-in route. Our server uses token-based authentication. When we get a sign-in request, the sign-in request will contain an email and a password through the body. And so upon getting the request, it will compare the password's hash with the user's stored value. If it's valid, it will send back a token. And so when the user wants to register an account, they'll access this endpoint, the /register endpoint, which uses these 2 functions, validate password and validate email, to validate the fields required. And so for validate password, you'll notice that we require capital letters, lowercase letters, special characters, and numbers, and you have to pass 3 out of the 4. And validating the email requires the email to match this regex. And so the register endpoint validates the email and password. Upon validating the fields, Bcrypt will hash the user's password and create a new user to store in our database, which will then save. When the user wants to modify their account, they'll access the account modify endpoint. So the request body contains the user's new email, their new password, possibly their new name, and their old password for validation purposes. First, we validate their authentication token in here, and then next we search for a user with their given email from the authentication token, and then if we can't find such a user, we know that the auth token is invalid. And then before we do any storage, we validate that their password is the correct one. And then if that's valid, we first validate that their new email does not exist in our system. If it does exist, then we obviously send an error saying that the email exists. Next, we validate each of the fields, assuming they exist. So if the user doesn't want to update their new email, obviously this won't happen. And then after validation is completed, we save all of the fields, like so.
Alright, so we're just going to show a demo real quick of the final mobile-friendly website that we have. So we'll just log in with a pre-made account. We'll sign in here, and we can show that it works on large screens, but it also does work on mobile screens. So if we go here, watch the nav bar collapse up here to work on whatever size screens we have, and you'll see these little cards will resize themselves as needed as well. And we can see what kind of activity summary they've had. So this one, we can check out their weekly summary. Total activities is 7, duration 6 minutes 51 seconds, calories 61, and total UV exposure 3,424. And then if we want to see more details on their specific activities, we can go here and show that this is also mobile friendly as well. It's collapsible and we can scroll through. So let's just pick on, let's say this one. So here we'll be able to see what that route was that they actually went on, graphed here on Google Maps. We'll see what the time was that they were biking, that they have 21 calories, their UV exposure, and they can also change what type of activity that was. So if they want to change it to walking, you can see the calories burned actually went down because they're not burning as many calories, and this will actually collapse as well to fit mobile devices. And then we can go ahead and go to just back around here to show that all of these work. Check out our manage, also works on mobile and full screen as well. And that's kind of what we were gearing towards, so that people can use it on whatever devices. So now let's kind of go into that code behind that we were showing earlier of what really happens when we're checking out that activities. So I'll talk about these endpoints in a bit, but let's go down to the other ones to start with. So the first couple endpoints are just to post that the particle is actually posting to. So I'll go over those a little bit later. But so these ones here, this get all activities, this was just a test function we were using to display all the activities of the user. It's not actually used in our front end anymore. Calculate calories just calculates the calories based off of what type of activity it was. And then here we have get all points. So this is the function that we use to actually get all the activity points based off of a specific activity ID, and this allows us to plot the latitude and longitude on Google Maps of each of those points for that activity. And it also allows us, if we wanted to, look at more details like analytics on that, but mostly we're just using it for latitude and longitude. And then we have the change mode, which was when we clicked on that drop down of the bike, run, and walk, and we were able to change that and get that updated calorie count. This is the endpoint that we were using there, and all we need is that activity ID. We'll change that endpoint. We use put because it's just updating a value, and here we can see we'll update that total calories, and then we'll save that there as well. And then we also have the display recent activities. That was that weekly display that we were looking at. So when we want to view that, we just make a GET request. All we need is them to have a authentication token, because we can grab that email from there. We'll decode that, grab that 1 week ago data, and then find all the activities within 1 week ago, sum up all those calculations on total calories, durations, UV, and then return that data. And then we also have the post single activity, which will be if we just wanted to view, when we were looking at that Google Maps, we just wanted to view that data on a single activity. So we'll use this endpoint here and just return the object of that specific activity given an activity ID. Now back to the top, what we're going to show in some later videos is how the particle actually interacts with the code, and we'll go into the firmware code as well. But on the server side, what we're doing is the particle will send a start activity post, and we'll take that, we'll verify that the particle sent all the data that we need to create a new activity, and that just is the device ID, API key, speed, activity ID, and start time. If all those are given, we just need to verify that the device actually exists. So long as it does, we can create a new activity for this device, and depending on what that original start speed was, we can determine what type of activity, what mode to set this in at the very beginning. The user can change that later if our prediction was wrong. But then we just create that new activity, save it, and we'll just send back a JSON that says, hey, we did start a new activity, or we'll send an error if there was an error. And then we have, after the particle sends that initial start activity, we'll get some activity points. And these activity points will keep track of latitude, longitude, speed, things like that we'll need later on to make the calculations. So again, we're just making sure that everything in the post is here that we're expecting. And you can see a couple extras. So we need the longitude, latitude, UV, and the speed now. And those all come in arrays from the particle. And then again, we'll verify the device. And then we'll just loop through all of those values that we were given in that array, update the UV, latitude, longitude, create a new activity, and we create a new activity point for every value in those arrays that were given, and then we'll use those later on to plot in the Google Maps. And that's basically what that's doing. And then once the activity stops, we have another endpoint to get that stopped activity. We'll make sure all the values are correctly given, verify the device is there, verify that activity actually exists. As long as the activity exists, we'll update that activity and say, okay, here's what mode it's in, here's what the total UV was, here's the total calories, and we'll update those things so that we can reference that later on. And we'll just send back a status that said, hey, the activity either wasn't started, and if it was succeeded, we'll just send, hey, activity updated, and it was stopped. And then the rest we went through, and we'll go into how exactly that works in the hardware side.
Worked. This home screen with account details such as email, username, threshold value, access token. Actually, let's go ahead. Yeah, and as you can see, there are also devices. You can actually add as many devices as you want. Let's just do one that should be deleted later. As you can see, it generated an API key for it, but if you want to go ahead and delete it, you can. It asks you for confirmation to make sure you don't delete it accidentally. Okay, as you can see, it deleted. And then, so let's go ahead and start the photon to get some data points. So let's go ahead to our serial monitor, which is actually running. So let's go ahead, let's restart that. Okay, so now let's go ahead and start collecting data. You can see this is an old UV threshold value, so let's go ahead and update it on the site. Let's update it to something like, say, 1,000, and let's switch back. You can see it was updated, so now it says 1,000. And just so you know, the GPS, since we're inside, there is no GPS fix. Actually, the GPS isn't even connected. So these data points is actually hard-coded just so we can get some data for this demonstration, and so we can view a route on the website. But as you can see, it's collecting data. So now let's go ahead and actually turn off the hotspot. So now we're going to lose internet connection for the device. I'm not going to be able to see it, but the photon starts blinking. It stopped publishing to the server and stopped receiving responses back, but let's just go ahead and stop the activity. As you can see, it's paused, and now let's go ahead and start the hotspot again. Okay, it's connected. As you can see, it's publishing all these data points. The server is logging them, and it was also able to update the activity and stop it, so I was able to calculate points for it. Now let's go to back to the website. Let's make it about 80. So let's just go ahead and do that change. And now let's start an activity again. As you can see, the UV threshold is now 80, but now let's shine a light on it. And so you can see the LED starts blinking, and this is to indicate that the UV threshold has been exceeded. So let's go ahead and stop that activity. And that's just the warning for the user to know that they've exceeded the user's set threshold, and they should probably stop. Code. For this portion of the video, we're going to only explain the firmware for the particle photon. So let's just open up the files in text editor. There are 5 files. The activity class and its header file, the activity tracker class and its header file, and the main UVFit INO class. So the activity class just holds vectors of latitude, longitude, UV samples, speed samples, index, which is just the order that they come in. status, which is what mode it's in, which is the very first post or the very last post or just a normal data point. So they hold up to 5 data points, and we figured out that 5 was the ideal number to publish as many as you can, but not be limited by the width that the particle cloud limits you to. So it also has a unique ID, which is just 20 random alphanumeric characters, which is generated by the photon. And so the let's go to the main UVFit INO class. And so in a file. So we need system mode semi-automatic and system thread enabled in order for it to work with that Wi-Fi. And then just some global variables. Last connected is last time it was connected to the particle cloud. So that way, if more than 1 day has passed, then it'll just delete the old data points. So then execute state machines is just run state machine. Threshold the UV threshold value is initialized to 1000, but it can be set later on by the website because of the update UV function, which is exposed through particle.function right here. And so that just uses scanf to convert the string argument into a threshold value. State machine scheduler just schedules state machine every 10 milliseconds. The LED status is to determine the status of the LED. And the reason for that is because we want the LED to be on when the activity is active, but we also want it to be blinking once the UV threshold has been crossed, and that's how we notify the user of the fact that happened. So the last bit holds the on-off state, and the second last bit holds the blinking state. And so the way that happens is every 250 milliseconds, then that will, if blinking is active, which is what this line does, then it will toggle the last bit, which means if it's blinking, then it'll toggle the last one from high to low or low to high, and then it will turn it either on or off depending on what the last bit is. And setup, expose, connect to the cloud, expose function, and then loop. This just goes, it just every 10 milliseconds it calls tracker.execute, so execute state machine, updates the GPS, controls the LED. Also publish counter controls. You publish up to 4 times per second, so every 250 milliseconds. This is for the case when you've been disconnected from Wi-Fi, but you connect again. So that way you don't want to publish too fast, otherwise the cloud won't get them all, but you don't want to do it too slowly, otherwise it will take forever. So we determined 4 times was the most you can do. And then this one is just to delete data. This if-else branch is just delete data if it's been more than 24 hours since your last time you were connected. So let's go to the activity tracker class, which is what we create one instance of here. The activity tracker class just holds the state machine and holds the current activity. So we have a queue of activities, which is for when you have been disconnected from Wi-Fi, you still want to hold on to the activities that you've done, and you want to hold them in a queue, so that way you'll publish them in the order that they came in, rather than something like a stacker or just a vector, which is harder to go through. Tick is to make sure that you collect data every second, because the state machine actually executes every 10 milliseconds, not every second. Count is just to count how many points you've taken. So when points equals 5, then it will post it instead of continue to collect. Order is the order of the points, because you're very likely to have activity with more than just 5 points, so you need to know which order they're in. Release is to not to demask the button, but to make sure that if you keep the button pressed, that it won't register as a second button press. Total UV is just to accumulate the UV exposure you've had, your GPS and UV right here. And then this is the state, last latitude and longitude. We decided that if you don't have a GPS fix, instead of just returning zeros, the get GPS latitude and longitude functions, they should return your last known location instead of somewhere random like off the coast of Africa, which is 00. So let's just go to the state machine. There are 6 states: wait, when it just waits for you to press activity start; first post, when it starts activity; collect, where it collects data point; waits 2, where it's just in between collections; post, when it posts the 5 data points are collected; and end post, which is when you end an activity. The way that for the posts happen is that it calls queue insert if and mode determines whether whether it's a normal data point, the first post or last post. Determining on that, it will push the appropriate object into the queue, and then process queue will determine whether you should make a post corresponding to start activity, a normal data point, or to the end of activity. And so process queue is called from the ino file every up to every quarter of a second right here. So that way it won't be called too often. Yeah, just go through the queue. Whenever it's connected, it'll just pop off points and publish them. And then you have your latitude and longitude, which said it will return most recent longitude and latitude if it can't find a current one. And then just get speed and UV data from the sensors and clear the queue if it's been more than 24 hours, which is called from here.